In part 4 of section 9, we're going to be looking at application problems, much like we saw at the end of section 8. So the initial purpose or the initial goal here is to determine what we are trying to find and specifically how many things we need to find, because that's going to tell us how many variables we're going to need for the problem. So let's take a look. It says a person invested $17,000 for 1 year. Part is at 10%, part at 12%, and the remainder at 15%. The total annual income from these investments was $2,110. The amount of money invested at 12% was 1,000 less than the amount invested at 10% and 15% combined. Then the final sentence says, find the amount invested at each rate. So this is a pretty typical narrative where there is lots of information at the very beginning, and then the final sentence actually tells us what we're trying to find. So there are 3 rates that we came across as reading, 10%, 12%, and 15%. So that means that there are 3 different amounts that we are trying to find. So it's important that we correctly define the variable, and for this definition, I don't think that we need to use anything fancy in terms of letters. We're just going to use X, Y, and Z. But as I said, it's important that we define the variable correctly. X is not going to be equal to 10%, which is what I see a lot of times is done. That would mean that you already know what X is. You're saying that it is 10%. But what we need to make sure that we do is think of this as the amount invested at 10%. That gives a completely different meaning to what X is supposed to be representing. Same thing can be done for Y. We can say Y is going to represent the amount invested at 12%. And for Z, we will say Z is the amount invested at 15%. So once we establish the variables, then we have to realize that for every variable that we have, there has to be an equation to go with that. So we have 3 variables, which means we have to have 3 equations. So somewhere back here in the narrative, there are 3 equations that we can write based off of the relationships that are given to us amongst the X, Y, and Z. So let's take the first sentence. Let's go back to the beginning. It says a person invested $17,000 for 1 year. So we have these 3 piles of money, if you will. X represents the money in the first pile, Y represents the money in the second, and Z represents the money in the third. So 17,000 is what you're going to get if you take all of these piles of money and compile them together into one. So all of those together should give me the total of 17,000. There's your first equation. X plus Y plus Z needs to be equal to 1,000. So let's read further. It tells us that we already know part's going at 10%, part is going to the 12%, and the rest is going to be going to that 15% pile. Then it says in the second sentence, the total annual income. Annual income. So this is known as the interest earned. Total annual income. This is the interest that is earned from the investments that are being made. So you have this sum of money that's sitting in the X account some money that's sitting in the Y account and some that's sitting in the Z account. Now, a percentage of the money that is in each one of these accounts is then going to be gifted to you as the interest earned. The gift that you receive is based off of the percentage that is in each one of these accounts. So when you're dealing with percentages in an equation, you have to be sure to represent them in their decimal form. So for example, 10%, we're going to need 0.10. 12% would be 0.12. 15% would be 0.15. So two ways to accomplish that. If you were to take 10% and then divide it by 100%, you would get 0.10. Or what I see a lot of students will learn from a science class is that you can just move the decimal place 2 to the left. So at 10, there's a decimal place there, move it 2 to the left, and then the decimal place is before the 1. And so that's how we can get 0.10. So do that for all of the percentages, and this is going to give us a second equation. 0.10 times x plus 0.12 times y plus 0.15 times z. So if you take the interest earned from each of the three amounts that we invest, which we know the total is supposed to be 17,000. So I have an error here. It says 1,000. This is supposed to say 17,000. Then that total will be the 2,110. So now we have two equations. We fixed that first one. The third equation is now going to come from the third sentence. Says the amount of money invested at 12%. The amount of money invested at 12%. Well, that's identical to what we wrote for y. Amount invested at 12%. It's almost identical. Amount invested at 12%. That's y. So this is saying y, and then it says was. Now was is going to be analogous to the word is, to be verb, and they represent the equal sign in the equation. So you can think of this as being the verbal explanation, and what we're trying to do is create the algebraic representation. So y is going to equal, and this is the part that gets to be a little tricky sometimes with the subtraction. It says 1,000 less than. That means that we're supposed to be subtracting 1,000 from something. So it doesn't make sense to say 1,000 minus something, because that means we're taking something away from 1,000. But instead, we're supposed to think of this as something with 1,000 less than that. So we're supposed to be subtracting 1,000 from something. So what are we subtracting 1,000 from? We're subtracting 1,000 from the amount that's invested at 10% and 15% combined. So let's write that. If I combine x and z, which are the amounts for 10 and 15% respectively, then I should take away 1,000 from this. And this would be a representation for my system. So we have the system, and once we get the system established, then we're going to be wanting to go through the solving process. So the solving process is going to require that we look at the three equations and decide how to get that down to two equations with two variables. So I'm going to leave that as an exercise for you to do, and I'm going to give you the result of that, that solving, so that way you can check it for yourself. What you should eventually get is that x is going to be equal to 4,000. Y is going to be equal to 8,000, and Z is going to be equal to 5,000. And then you would want to take this information and you would want to write it as a sentence to give a final answer for the application problem here. Now I will give you one hint before we end this, this example. The third equation you might think about rewriting it so that way it is with all the variables on one side and then the constant on the other side. So it would look something like this. If you were to rearrange things, it would look like x minus y plus z is equal to 1,000. And then you might think about using elimination with the first equation and the third equation as a place to start your solving process. And you know what, I'll give you another hint as well. Something that might also be helpful for this second equation, since you have these decimals in here, if you just start before you try to pair it up with anything, just go ahead and multiply the whole thing by 100, and then you'll get a new version of this equation without the decimals. It'll say 10x plus 12y plus 15z is equal to what looks like 211,000 now. So it makes the constant bigger, but then it also makes the decimals bigger and turns them into whole numbers there. So just some suggestions that might help you as you begin to try the solving process with this one, and hopefully you'll get to those final results.